Most people think that robot fails because of bad AI, but the reality is robots fail because of bad engineering processes. Today I'm going to show you how DevOps principles are used in real-world robotics companies like Boston Dynamics, Nvidia, and Waymo. And without DevOps, robotics cannot be scaled. This is not theory. This is how robots are built in industry. In robotic industries, this is often called RoboOps or Robotops. The robotics industry is rapidly growing. We are seeing commercial quadruped robots, autonomous warehouse robots, service robots, and humanoid moving from lab into real customer environments. As adoption grows, robotics teams faces serious challenges. How do you ship fast without breaking safety, reliability, or trust? This is the same problem software teams faced years ago. And that's exactly where DevOps come in. High performance team uses continuous integration, continuous deployment, automation, and observability. But robotics adds hardware, physics, safety, and real world risk. So the question becomes, can DevOps principle be applied in robotics? The answer is yes, with adaptations. This itself is RoboTops. Why robotics is different? Let's understand the unique challenges in robotics. The first one is hardware dependency. Unlike software, robots interact with physical world. Testing is constrained by hardware availability, space, cost, and safety. Second thing is safety and real world harm. A software bug might crash the app, but robotics bug can damage property, injure people, or destroy hardware. Third thing, non-deterministic systems. Robots are not deterministic. They are unpredictable. Sensors are noisy, environment changes, and physics is unpredictable. This means traditional fixed test cases are not enough. Robotics testing must include randomness, repetition, and stress conditions. Fourth, limited test hardware. Most teams share limited robots, often restricted to lab, garage, or parking area. So, how do companies ship fast and safely? Even in robotics, the four DevOps metrics still matter: deployment frequency, lead time, mean time to recovery, change failure rate. Robotics companies that succeed optimize these metrics just with robotic specific tooling. The next is tools, simulation in CI. The first and most important DevOps adaptation in robotics is simulation driven CI. What is simulation? Simulation allows us to test robot behavior in a virtual environment that approximates the real world. Why simulation is DevOps friendly? Because there is no hardware dependency, runs on laptops of developers, and can be used through cloud, containers, and can be run in parallel faster than real time. This makes simulation perfect for continuous integration pipelines. Every code commit triggers, unit tests, simulation tests, scenario replays with noise injection. If simulation fails, the change never reaches the hardware. So it benefits in three ways: higher deployment frequency, lower change failure rate, and the developer's confidence is maintained. And the downside is simulation takes effort, compute, and maintenance. For simple robots, it may not be worth it. So next one is hardware in the loop CI. Simulation is powerful, but it's not enough. Why is hardware in the loop? This means automatically testing real robots using CI pipelines. So if you follow this flow, code commit, unit tests, simulations, deploy to test robot, run real world tests, collect logs and metrics. This removes manual testing pain and supports frequent small changes. So whenever robotics companies skip this step, they discover bug in the production. There are four types of benefits of DevOps over here. The first one is push changes and just forget. The second is alert notify failures. And third is faster MTTR. And fifth is safer releases. This is continuous fleet deployment. Once robots leave the lab, you are no longer deploying software. You are managing a fleet. What is a fleet? Robots are distributed across buildings, cities, countries, unreliable in connectivity and different environments. How DevOps handles this? Industry uses stack deployment, stacking fleet, production fleet, canary deployments, rolling updates. If a problem is detected, systems automatically roll back. The tools which can be used over here is AWS Greengrass, Formant, Rocos. So why automation is critical over here? Faster bug fixes, low MTTR, minimal customer impact, scalable operations are the main points. Next is cloud DevOps and robotics. Modern robotics heavily relies on cloud DevOps frameworks. And what are the benefits? OT updates, real-time telemetry, edge computing, security enforcement. Actually, research shows that cloud DevOps improves scalability and reliability, but introduces challenges like security, complexity, and skill gaps. This is why robotics companies invest highly in DevOps engineers. So let's come to the final summary. What did we learn? DevOps is used in robotics. Simulation is CI. Hardware in the loop is equal to quality gated. Fleet deployment is CD, and the cloud DevOps is equal to scaled. These tools are not silver bullets, but together they enable robotics team to ship faster, safer, and at scale. Modern robots are not programmed. They are deployed, monitored, updated, and rolled back. If you are a robotics engineer, learn DevOps, and if you are a DevOps engineer, robotics is your future. If you want more industry grade robotics content, then subscribe now.